In this session, we will look at some of the events which can be used for triggering a workflow. So this is the GitHub Actions official documentation page, which describes all the events that can be used as a trigger for a workflow. So we can define the workflow to run when a specific activity on a GitHub happens, such as a push event or a pull request, or we can also trigger them at a scheduled time using a cron job, or when an outside event occurs. So these are the different events which can trigger, and this documentation page provides a detailed examples of each and every trigger point. So far in all of our workflows, we only used the push event. Like, we push some changes to a repository, the workflows get executed. But you can also use events such as pull request, or whenever issue is opened, edited, deleted, or assigned, and whenever there is a fork, and whenever you push anything to a registry package, right? So there are many different types of events available. So in this session, we'll explore a few of them. So we have already seen the push event. So we will also look into the schedule event, which is, executing a workflow using a cron job, right? So you can also define cron jobs. So if you're not aware of cron job, so I would request you to, check out the brief understanding about cron job, using Google or some other means. We'll just use a simple cron syntax in our example. And apart from schedule, we'll also look at the workflow dispatch event. So whenever you want to trigger a workflow manually, we can configure this workflow dispatch event. And with this event, we can also set up inputs as well. So you can also provide some inputs which can be used for testing the workflow on different environments and with different values. So this is how you define the workflow dispatch, and optionally, we can also define inputs. So the inputs could be of different types, like it could be a choice type, a Boolean type, or it could be of type environment, right? So these are the different input types. And when you give this, so this is how the UI looks like. So when you want to run this manually, it gives you a small UI where we can select the environment, the log levels, or the different inputs, whichever we have given, in this workflow. Okay, so let's go ahead and see some basic examples on this. So I'll be working with the same, exploring variables and secrets workflow. So here, I'll just comment out the push. I don't want to use a push for the time being. So let us see what options we have. So we can use Control Spacebar, and it's going to display all the events which can be used at this point. So this gives you the entire list, whatever list we just saw in the documentation, all the options are available here. So let us use the schedule event. So we need to use a cron job, and I'm just going to use a simple cron job, which is going to execute this workflow every minute. So if you're new to cron jobs, so you can also, use some external websites. So one website which I would recommend is the cron tab guru, where you can just paste in the, cron syntax, and it's going to explain like, when it's going to be running. So this example will be running at every minute. Okay. So let me, and I'm using double quotes over here, or you can also use single quotes because I'm using some special characters in this YAML specification. Okay, so let me just commit this. And push it. So let's go to the Actions tab. And here, it's not yet triggered, but I just want to highlight couple of points over here. So if you see here, this was the workflow which was executed earlier with a push event. So here you can see that, it gives you the commit ID, and it gives you the event which is pushed and the user who pushed it. So these details are available for each and every workflow which gets executed. So it also logs the event which triggered the workflow. So in this case, it is a push event. Okay. So let me refresh this page. So the cron schedules are random. So I guess we have to wait for a whole minute. So let me just pause the video. Okay. For some reason, the cron scheduler is not triggering the workflow for the time being, but it usually does trigger the workflow, but I'm not sure why it's not working at this time. So let us move forward. So let me comment the cron scheduler and add in a new event. So let me add a workflow dispatch. Okay, I don't want to add any inputs for the timing. I just want to manually trigger this workflow. So before I commit this, if I go here for exploring variables and secrets, I don't see any button where I can manually trigger the workflow, right? So once I commit this workflow dispatch event, so there should be a new button which should be used for manually triggering the workflows. So let me add a commit message and push this. Okay, so once it is pushed, and if I refresh this page, I should see a new button over here. So let me refresh. And now you can see we have a new run workflow button, and this is, displayed because we are using a workflow dispatch event trigger. So now I can just run this for different branches. So we only have one main branch. So let me just run the workflow manually. So let me refresh the page, and you can see that a new workflow is executing. And if you see here, it is shown that, it was manually triggered. So earlier it was shown that it was triggered due to a commit which was pushed, but now it's saying that it was manually triggered. Similarly, if a job is triggered using a scheduler, it would show scheduled over here. And it was, if a job is triggered when a pull request is raised, it will show you pull request. So based on the event which was used for triggering the job, the workflow, it's going to display the event name over here as well. Okay, so that's how we can make use of different events within workflows to trigger them. In this session, let's understand how concurrency works in GitHub Actions. So we'll make use of the same example or the workflow which we have used in the previous session. So here we have two steps, or two jobs. Basically, we have a Docker job which does the Docker building and a deploy job. So in the deploy job, I just want to add an echo. So I just want to sleep. I'll just add a sleep command for 600 seconds to explain how concurrency works here. Okay, so this job is going to run approximately for 10 minutes. Okay, and let me quickly save this. Let me add a commit message and push it. And here I'm only using the workflow dispatch as a trigger event. I can also use push as well, but I've not enabled it for the time being. So let's go and manually trigger this workflow. So I need to click on run workflow over here. So this is going to start or trigger a new workflow. Okay, and let me go. So here, this is going to take a while because we added a sleep command in the deploy job. Okay, so let's wait for a few minutes or a few seconds. So let's assume, this is a job which is a long running job. Okay, and it takes like 10 to 15 minutes to run. Okay, so in the meantime, someone or from your team might have pushed some changes, and a new trigger might have triggered for running the workflow. So here, let me manually run a workflow for you. So I can also run another workflow. Let me refresh, right? So here I'm manually triggering the workflows, but in real-time scenario, it could be one of your team member or someone raised a pull request and a trigger is, triggered the workflows. So here, if you see, both these workflows will be executing the deploy job. So ideally speaking, in real-time scenarios, you don't want to have two deployments happening at the same time, most probably in the production environment, right? So this is not a good practice. You don't want two deployments running at the same time. So this is where concurrency comes into the picture. So in GitHub Actions, concurrency key ensures that only one workflow runs or a job is in progress. And we can use the key at the workflow level and at the job level as well. And along with this concurrency, we also have a couple of options, like you can give it a group name and also a cancel in progress key. So let's understand both of them. Okay. So before I do this, so let me just cancel the workflows. I don't want to consume 10 minutes of my, free account limit, right? So let me just cancel both the running workflows. Okay. And then, so how do I enable concurrency for the deploy job? Okay, so this can be enabled at the workflow level as well. So if I go here and if I do control spacebar, I can see there is a concurrency option. Okay, so but I want to do this at the job level, specifically at the deploy job. So here, let me just add concurrency, and it takes in two parameters or two keys. So you can have a combination of group and cancel in progress. So group is nothing but, you're giving it a unique name. Okay, so let me just give a name like, production deployment. And I can also add another key, which is cancel in progress. So it is going to cancel any current running jobs or workflows within the same concurrency group if you specify this as true. So it takes a Boolean as an input, true or false. So if I give true, so any existing workflow which is running, it's going to cancel it and run the newer, workflow. Okay, so that is the configuration which I've added over here. So let me commit this. Okay. So once it is committed, so again, I can go, so this, I've canceled the job. So I need to go back, and so this way cancelled. So let me trigger a new job. So it's going to take some time. So first the Docker job is going to run, and then the deploy job. And as usual, the deploy job has a sleep of 10 minutes. So once it is in the deploy job, so I will trigger another workflow, and I'll show you, how the concurrency works. So now you can see that the deploy job is indeed running. Okay. So now let's go and trigger another workflow. So let me go to exploring variables and secrets workflow and trigger this. So now what happens is, so let me refresh. So another workflow is triggered. So the first job is going to run as usual without any errors or issues, because we don't have any concurrency at this Docker job, but we do have it on the deploy job. So let's see what happens. So here in the second trigger workflow, the deploy job will start. Okay. And the reason why this is going to start is we have used cancel in progress. So when I started the second, or when I triggered the second workflow, the workflow for the second time, it is going to cancel any in progress workflows. So the first workflow which I've triggered should be cancelled. So as you can see here, if I open this, it should see that the operation was cancelled, and this was cancelled automatically by the concurrency option. Okay. So let me go here. So this second workflow will be running. So if I go back for the summary, and if I scroll down, you can see an annotation. It's going to display the errors. So it's saying that the deploy job was cancelled since a higher priority waiting request for the production deployment exists, right? So since we triggered a new workflow, it cancelled the in progress one. Okay, so that is how concurrency works. It allows only one job or one workflow to be running at any given point of time. Okay, so that is how concurrency works. So if I change this to false, and if I try to create a second workflow, try to trigger a workflow for the second time, it's going to cancel the second workflow. Okay, so let me quickly show you that as well. So let me just use false over here, cancel in progress, and let me commit and push this. Okay, so we already have one workflow which is in running state. Okay, so let's see what happens if I trigger a new workflow. Okay, so let me go back and try to trigger a new one, but this time we have cancel in progress as false. So the currently running workflow will not be cancelled. Okay, so let me trigger a new one and see what issue or error it's going to give us. So if I open the newer workflow which got triggered, so the first job will run, but the second job, if you see, this is in waiting mode. So it is going to wait till the previous job is completed, right? So that is how concurrency works. It won't cancel the newer one, but it will wait till the previously running or the currently running workflow completes the job. Okay, so if I open this, right, so it's going to give me a log message saying waiting. The workflow is waiting on deploy job to complete before running. So if I click on this, it's going to take me to the workflow which is currently, executing or running that specific job. Okay, so that is how concurrency works in GitHub Actions. In this session, let's understand what is the use of the timeout option in GitHub Actions. So let's take our previous example. So for testing purpose, I have set up a sleep command for 10 minutes, which is like 600 seconds. By mistake, let's assume the developer, instead of 600, they have used 6000 seconds, which is equal to, almost like 10 hours. So if you don't monitor this and, if you have done this by mistake, your workflow will be running for 10 hours. And by default, the GitHub Actions will kill the workflow after 6 hours, which is 360 minutes. And not only this, sometimes the workflows might keep on running due to a memory issue. And at that times, again, the GitHub Actions automatically kill the workflow after 360 minutes, which is almost 6 hours. And in this 6 hours, you lose your GitHub Action minutes, and it's going to cost you a lot of money. So this is the place where the timeout option comes into the picture. So the timeout option can be mentioned at the step level or at the job level, and it makes sure that the workflow is terminated if it does not complete within the specified timeout period. So here, I'm just going to use this as 6000 seconds, but I don't want this job or this step to run for more than 1 minute. And I want to automatically, cancel or terminate the job. So what I can do? So at the step level, I can simply search for timeout minutes. So this is in minutes. If I give timeout minutes is equal to 1, so it's going to expect that this step should be completed in less than 1 minute. If it takes more than a minute, it's going to terminate the job, right? So the same timeout in minutes can also be given at the job level. And if you give it at the job level, this is going to be applicable for all the steps within this job. Okay, so let me just add this at the step level. Okay, and let's check this out in action. So let me just add timeout minutes, commit this. Okay, so I have not enabled push. I keep on forgetting. So anyway, let me just manually trigger this. So let me click on run workflow. And we need to wait for a minute to see the error message or to see the workflow getting, automatically, cancelled. So let me just pause the video for 1 minute. So here you can see that the workflow has failed. And if you see the comment over here, annotation, it's saying that the action has timed out and it is in the deploy job. So let me go and check the logs of this. And as you can see here, it took around 1 minute and 13 seconds. And since it was more than that of the timeout limit, the action was timed out and it simply, failed the workflow. So this is how the timeout option works in GitHub Actions. in this session, let's go ahead and understand the use of matrix strategy within GitHub Actions. So let me go to the example. So I have created a new matrix configuration workflow YAML file. So let me first commit this and then explain the code over here. So let me just commit and push this so that the workflow gets triggered and executed. So here, this is again a straightforward workflow configuration file. The name of this workflow is matrix configuration. It's going to be triggered on a push event as well as a workflow dispatch event, and it has two jobs. So the first job, I'm going to deploy this on a Ubuntu virtual machine where I'm just checking the Docker info, and I'm going to deploy or run a Docker Hello World image. So here, Docker comes pre-installed in all of the GitHub hosted virtual machines, so you don't need to install Docker. Similarly, you might have a requirement where you want to run the same Docker image on a different operating system such as Windows or Mac OS. So here in the second job, I'm running this on a Windows operating system, and I'm running the same steps again and running the same image. So let's see this in action. So since we have already pushed this, so let's go ahead and check out the workflow logs. So we have this matrix configuration. A new one is in running progress. And as you can see here, both these jobs are successful and both of them are running in parallel. Okay, so if I go to the deploy on Windows job, so it's going to show you the details about the operating system. So it's using Windows Server 2022. Okay, and here it's just showing you the Docker info, the output of the Docker info. And if I scroll down, it's going to simply download, pull the Hello World Docker image, and simply run the Docker image. Okay, so this is how it works. So this is a common scenario, right? So in most of the scenarios, like if you want to build an application or if you want to test applications on multiple different operating systems or on multiple different, programming versions, so we can have, or ideally speaking, we can have multiple jobs defined here for each operating system and for each different version of the programming language. But sooner or later, it's going to be complicated because you will be repeating the same lines of, code or steps again and again for multiple different operating systems and for different versions. So to avoid that, in GitHub Actions, we have the concept of matrix strategies. So this matrix strategy lets you use a variable in a single job definition, which automatically creates multiple jobs which run in parallel, and it is based on the combination of the variables which we pass. And it could be used for running a single job on multiple operating systems and on multiple different versions as well. Okay, so this is how the syntax looks like, but I'll modify our existing job to run on different machines. Okay, so what we will do here is, so I want to, so here in this example, we are just running this on two different machines, Ubuntu and Windows. Even in the Ubuntu, I think we are using the latest version, which is 22.04.3 version. So let's assume, we have a requirement where we want to, deploy and test this image on different Ubuntu machines like version 22, 20, 19, 18, and also on Windows. And not only the Hello World image, we also want to test other images which we have built. So what we can do is, we can go to this. So we only need one job when we make use of matrices. So in this job, let's modify this and make use of matrices. Okay. So let me modify this. So here, I need to define a strategy. Okay. So in this strategy, you have three options. So in this session, let's only talk about the matrix option. So in the matrix option, you need to define variables. So the first variable which I want to define is the operating system, and you can use any key of your choice. Okay, so these are your own choices. Okay, these are not GitHub Action keywords. So I just want to create a key called as OS, and you can give an array of options over here. So I want to run this job on multiple operating systems, and I need to give the names of the operating system. So I want to use Ubuntu latest. I want to use Ubuntu, and I want to use 20.04, and I think I want to use Windows latest as well. Okay, so I want to run this job on this 3 different operating systems. And apart from this, I also want to mention the images which I want to use. Okay, so I would like to use 2 or more images to be tested. So one is the Hello World image, which I want to test, and the other one is the Alpine image. Okay, so let's assume this is what I want to do. So here, what happens is, so how do I refer these values in the job? So in the runs on, you should not hard code the value. So now you need to be referencing this OS values. So the syntax here is you need to use $, double curly braces. And here you need to mention matrix dot OS, right? So now it's going to take the value from this array. And similarly, I think we need to also make a change here in the Docker images as well, right? So here we are going to use $, curly braces, and it should be matrix dot images. Okay, so this is how it's going to reference both of these images. And also you can also use this syntaxes in the step name as well. Okay, so running image on, so you can also use a dynamic string over here. So it's going to give a log message saying that it's running the image on Ubuntu, on Windows, and so on and so on. Okay, so here what happens here is, so it is going to create 6 different jobs for us because we have 3 operating systems and 2 images. So it's going to be a combination of both these variables. So 3 into 2 is 6. So it's going to create 6 jobs, and all the 6 jobs will be running in parallel. Okay, so you can also use Mac OS if you want, but I'm not using it for the time being. So let me just add this or commit this quickly. So let me commit it. So let's go here. So if you see, a new workflow has been triggered. So let's go here. And you can see here, this is a matrix deployment, and all the 6 jobs are running in parallel, right? Since we have a combination of Ubuntu latest, Ubuntu 20.04, Windows latest. And if you see here, each operating system is running 2 images, and it is logged, everything is logged over here. So out of 6, so it completed 4 jobs, which involves the Ubuntu operating system. And now the Windows jobs are currently in progress. Okay, so you can open any one of them. Let me just show you the logs. So this is using, as you can see, Ubuntu 22.04 operating system. You can see the Docker details, and you can also see the run image on Ubuntu latest step name, and also some output with respect to the Docker run image command. But here, if you see here, one of the job failed. Okay, so let me go to summary, and you can see here, out of the 6 jobs, the Windows latest job, which is running the Alpine image, has failed. Since this job was failed, any jobs which are in progress will also be automatically cancelled. And the entire workflow, the status will be in failure state. Okay, so that is the default behavior. Okay, so whatever images which run in Ubuntu might not work on other operating systems. And one of the example is Alpine. So the Alpine image works fine on Linux operating systems, but it won't run on the Windows operating system. Okay, so it gives you some error saying that no matching manifest for Windows AMD 64 architecture, basically, right? So this is a known issue, and the error is also expected in our scenario. So what we can do here is, in such scenarios, we also have an option to ignore certain images for certain operating systems when you are making use of a matrix strategy. So we are going to check it out in the next session. Okay, so let's go ahead and check out a few additional features of the matrix strategy. So in our previous example, so the Windows machine was failing because it could not run an Alpine image. So we will try to rectify that in this session. And whenever a job fails, the default behavior in the matrix strategy is it is going to stop, cancel any running jobs or any jobs which are in queue. And that is what happened with the other Windows job. So this is a default behavior. And we can also, bypass this by using a variable. Okay. And one more thing, what we saw in this example was, so all the 6 jobs started and executed in parallel. So if you have a combination of 10 jobs, so all the 10 jobs will be running in parallel. That is a default behavior. So if you want to control, the number of jobs to be run in a matrix strategy, it can also be done using a keyword. Okay. So let's try to understand this in today's session. So let me go back. So here, the first thing which I want to do here is, I don't want the Alpine image to be executed on the Windows machine. All right. So how do we exclude this? So specifically, we have a exclude keyword, and we also have include as well. So we'll learn about it as well. So in the exclude keyword, you need to make use of the same keys which we have used earlier. So let me use, images. So which image do we want to exclude? So we want to exclude the Alpine image. And where do we want to, exclude this? So you need to give the operating system and you need to mention the name. So I want to exclude this on the Windows latest operating system, right? So what this is going to do is, so this Alpine image will not run on the Windows machine. Only the Hello World image will be executed on the Windows machine. So now if you calculate this, it's only going to run 5 jobs in parallel because we excluded one of the image. Similarly, if you want to include any new, images, so you can also use the include tag. Okay. So in the include tag, so let me just copy this. So you can include images which can be added to the existing list. Okay. So here, let's say, I want to run a different flavor of Alpine, which is of a different architecture. Let's say AMD 64/Alpine. And I only want to run this on the Ubuntu latest operating system. Okay. So let's say on this one, Ubuntu 20. Okay. Right. So this image is only going to be run on the Ubuntu machine, which is 20.04 version. Okay. So this is how you can make use of exclude and include, options or keywords in the matrix. Okay. And before I commit it, so you can also add few more keywords. So you also have fail fast and max parallel. So what is fail fast? So by default, this is true. Okay. So it is going to cancel any jobs which are running or in queue when a job fails, right? So you can also disable this by using false. And the other option is max parallel. So here, if you see this configuration, so total, it's going to run 6 different jobs in parallel. So all the 6 jobs will be running in parallel. So if you want to control the number of jobs which can run simultaneously using this matrix job strategy, you can define the number over here. So if I give the number as 2, so what it's going to do is it's only going to run 2 jobs at a time. So once 2 jobs completes, it's going to start the next set of 2 jobs. Okay, so that is how this matrix strategy works. So let me commit this. Okay, so let's push this. Okay, so let's go back. A new job or a workflow started. So again, we have 6 jobs, but here you can see that, all the jobs will not start in parallel. So if you see, only 2 jobs are running now. So once these 2 jobs are completed, it's going to start the next 2 jobs. Okay, and as you can see here, the Alpine image is not run on any Windows operating systems. So on Windows operating system, only the hello world image is going to be executed. And whereas this AMD 64/Alpine image is only run on the Ubuntu 20.04 version operating system. Okay, so this is how the matrix strategy works in GitHub Actions. I hope you got a good idea about it. So let's understand what is a context and how to use them in a GitHub Action workflow. So in GitHub Actions, a context is a set of predefined objects or variables that contain information about a workflow run. So this context can contain information about the environments, events, variables, runtime environments, secrets, jobs, steps, and various other options. So each context is an object that contains properties, which can be a string or some other objects, and you can access them within your workflow. So in this documentation page, it gives you the various different contexts which are available and how to access them in your applications or in your workflows, basically speaking. So in this demo, I'm just going to run a sample workflow, which is going to display all the contexts available at different levels. Okay, so so there is an example available over here, so which is context testing. So it's going to dump the context to the logs. So we can use the toJSON function in order to display the JSON content for us. Okay, so here we have multiple steps. So it's going to give us the context for the GitHub event. We have a context for jobs, steps. We have the runner context. We have, if you have metrics and strategies defined in your job, you can also get the context for those specific keywords as well. So not only this, you can also get the context for secrets, inputs, needs, and for other environments as well. Okay, so for the time being, let me just copy this till here. Okay, so let me just copy here. So let me go and create a new configuration, workflow config. So let me just name this as context testing.yml and paste this. So I'm just going to use this for the push event. I'm not going to change any name. The only thing which I want to change here is, instead of strategy, I want to check the secret context. So whatever secrets which are accessible to this workflow. Okay, so I need to use toJSON. I need to use a secret over here. I think secrets, right? So let me quickly test this out. So I can go to the documentation, secrets. So you can use this as secrets.github or secrets dot the name of the secret. Okay, and if you want to get some runner configuration details, which is nothing but the virtual machine where you're running it, you can use runner.name, which gives you the name of the runner which is executing the job. If you want to know which operating system the runner is using, you can use runner.os. So these are basically used if you want to have any conditional logic for if conditions, so which we will be exploring the next session. Okay, so let us quickly understand this. So let me dumping secret context. So I'm just dumping the different context values in the log so that we understand how it works. So context testing is the commit message. Let me post this. Okay, so I guess a few more workflows will be running in parallel. So if you see here, the matrix configuration is also running in parallel because I have a event push enabled for that as well. So let me disable this quickly for the matrix configuration. I want to disable this workflow and I want to cancel the run as well. I don't want to waste my GitHub action minutes. So let's go to context testing. So it is successfully completed. So let's go and check the logs. So it's going to dump all the context to the logs. Okay. So here, let's first check the GitHub context. So what data is available, for the workflow, which can be used in our workflow. So let me expand this and you should be seeing a huge JSON. right? So in this JSON, it's the first one is about the GitHub token. Then it gives you the data for the job, which branch it's using, what is the repository name, who is the owner of the repository, the owner ID, some details regarding this run, and a lot of events like who committed this, what is the details of the author, right? So a lot of details. So these are all GitHub event, context details. So all these variables can be used within our workflow. Okay, so there are a lot of data available here. And if I go down, we have the job context. So it's going to give me the status of the job. Is it successful or not? And then step, I think we don't get anything in the step for the time being in this example. So let's check the runner context. In the runner context, it's going to give you the details about the runner which is running this workflow. Okay, so it's going to give you some details about it. And lastly, we have manually added the secret context. So this workflow has access to two secrets, which is the GitHub token, which is created by default for all the workflows, and the Docker password, which we have created in one of our earlier sessions, right? So this is how, you can make use of these contexts within your workflow, right? So we have few other contexts also available. So we'll be exploring them and using them, in the upcoming sessions. Let's have a look at expressions within GitHub Actions. GitHub Action expressions are used to dynamically configure workflows to execute jobs and steps based on conditional logic. The two primary conditions which come into play are if and continue on error. We will talk more about continue on error in a later session. So in this session, we'll talk about the if condition. The if condition allows you to control whether a particular step or a job should proceed based on a defined condition. The if condition is typically used within a jobs or a steps configuration to determine its execution. An expression can be any combination of literal values, reference to a context, or functions. And we'll also talk about functions at a later point. As seen earlier, context are a set of predefined objects or variables which contain relevant information about the environment event or other data associated with a workflow run. We can use context to access information about the workflow, such as the branch that was triggered, the workflow, the commit that was pushed, or the runner details where the workflow is getting executed. So these are some of the most commonly used, context variables. In this session, let's understand how to use the context variables using the if expressions. So let's go to the job. So here, let's assume, we want to make use of some of these context variables within our job. So how do we use them? So we can use them using expressions. So expressions can be used to programmatically set environment variables in a workflow file and also access the context variables. So we can use the if keyword along with the condition or the expression which can be used for accessing the context variables. Okay, and you have a lot of options, like you can use literals, operators, functions, and some filters as well. Okay, so in this example, let's have a very simple use case. So here, what I want to do here is, so let's go to the, let's say, I want to go to the, variable secrets, workflow. And here, if you remember, we have two jobs, the Docker job and as well as the deploy job. So what I want to do here is, I only want to deploy or run this deployment job when it is in the main branch. So if this or if any changes are done in the, feature branches or any other branches, I don't want to execute this deploy job. So the deploy job should only be running in the main branch. So how do I add that condition? So you can use the if expression. And how do I use the context variables? So here I need to make use of the GitHub context variable because I want to check, if the branch is main branch or some other branch. So here So this is the log which I got it from the previous thing in the previous run. So here I can make use of this ref variable, which holds, the branch name or the branch tag related to path of the branch, right? So here, how do I access this within my GitHub action workflow? So I need to use github.ref because this is a GitHub context variable. So I need to use github.ref equal to refs head main. So here I need to use GitHub dot, you can do control spacebar. It's going to show you all the different keywords which are accessible for this GitHub variable. So I can just use ref equals to operator, and I want to use single quotes ref heads main. So now this deploy job will only execute if it is part of the main branch. Okay, and it's going to be skipped if it is part of some other branch. So to understand this, so what I want to do is I want to raise a pull request. Okay, so I want to raise a pull request. So in order to raise a pull request, I guess first we need to have a feature branch. So let me just push this or create first let me create a feature branch. So let me go here, or I can just click on main at the bottom. So it's going to ask me if I want to create a branch. So yes, I want to create a branch. So let me just type this feature/testing. I'm just going to create a branch called as feature/testing. Yes, I want to switch to the new branch. Okay, so on this new branch, I want to make the change. Okay, let me close this. Let me go to variables secret. So here on the deploy job, I just want to add if github.ref is equal to main, then only I want to execute this deploy job. So let me push this to the feature branch. So here, if you see, I'm currently on the feature/testing branch. Okay, added if expression. Okay, so let me also use push over here. Okay, so let me quickly use a push. I think I need to use a colon over here. Okay, so once it is committed, so I guess I need to go to the actions. In the actions, I need to go to variable. And of course, this is currently in disabled mode, so it won't run it. So let me manually, okay, I need to enable this workflow first. Okay, so let me enable the workflow. And let me run this manually. Okay, I think I need to, okay, so let me just push this again from the feature branch so that it executes automatically. So let me just make a small change. Instead of 6,000, I'll use 600 seconds. I'll just use some dummy commit message and push it because I want to test it from the feature branch. Okay, so I don't want to test it from the main branch. So once you do that, so a new workflow will be executed, and as you can see here, this is getting executed from the feature testing branch, not from the main branch. Okay, so let's go here. So here you can see that the Docker job was successfully completed, but the deploy job was skipped. So let us see the log message over here. So it's saying this job was skipped. The reason why this job was skipped here is because we added a condition saying that this job will only work on the main branch and not on the other branches. So now what we can do here is, so we can raise a pull request. I guess I'll just do it using a different UI. So let me go to code. So we have this new branch changes. So let me just compare and raise a pull request to the main branch. So from feature testing, I'm raising a pull request to the main branch. So let me just add a message, testing if expressions. Okay, and let me create a pull request. So since this is a demo, so as you can see here, we'll talk about the pull request and the other approval specific rules in the upcoming sessions. So here, let me go and refresh this. Okay, so it's just going to say that there are no conflicts for the time being. So let me just merge the pull request, and also it also successfully ran this workflow earlier. So since there were no errors, it's just saying that all the checks have been passed and it is ready to be merged. Okay, so if you don't get this, it's fine. We are going to explore this more in the upcoming sessions. Okay, so let me just click on merge pull request, confirm the merge, and it's going to be merged to the main branch. Okay, so now as soon as it is merged to the main branch, if I go to actions, if you see, a new workflow is in action. So whenever a merge is completed, so you can see that it is executing this workflow in the main branch. Okay, so earlier it executed in the feature testing branch, but now it's getting executed in the main branch. So let me go here, and now you can see that the deploy job is getting executed because now the condition matches. Since the condition is matching, the job will be executed, right? So this is how you can make use of expressions and use the context information to add some conditional logic for your workflows. In this session, let's explore the different types of workflow event filters and activity types. In one of our earlier sessions, we discussed about triggering workflows using different events like push, workflow dispatch, scheduler, and few others. But we have not talked about filters and activities. So in this session, let's talk about them. So let me give you a couple of examples. So if I go to the pull request, so we can, have various activities for a pull request, right? So for a pull request, we have activity types like assigned, unassigned, opened, closed. So we can add, or the workflow can be triggered on each of these activity types. Similarly, if I go to the push event, so the push event, we don't have any specific activity types, but we can use filtering. So we can filter on which branch, the workflow should be triggered on which, right? So let me go ahead with an example and explain few of these examples. So let's go and create a new workflow. So let me name this as workflow filters.yaml. Okay, it created outside the .github folder. So let me move this inside. Okay, so let me paste it. I already have some code and I'll explain you the code. So let me just minimize everything. Okay, so here I have a job. So I'm not giving any name over here. So if you want, you can also mention a unique name. So let me name this as exploring workflow filters. Okay, and activities as well. Okay, so let me just say workflow filters and activities. Okay, and here we are triggering this workflow on various events such as a workflow dispatch, a schedule which runs on a cron job every 59 minutes. We have a push and a pull request. And we also have a job which just echoes like when this job was executed for which event type. And we are not hard coding the event type. So we are getting the name of the event using the GitHub context variable. Okay, so schedule, I'm just going to remove this because it's not working as expected. Okay, so in my scenarios, I'm just going to comment the schedule part. So first, let's understand the push part. So here in the push part, we don't have any activities for push, but we can use filters. So two of the filters are branch ignores and branches. So you can use either of them. You can't use both of them in in the same push event. Okay, so let me just remove the branches for the time being. So here, if you use a filter of type branches-ignore, so this is going to exclude these branches. So whenever there is a push to these branches, it is going to ignore and it will not trigger the workflow, right? So here you can give the names of the branches. You can also use wildcard entries like #. If you use a single #, the name of the branch could be something like this: feature /add music or /update images. If you want to use multiple slashes, you can use double * as well. Okay, so this is how the branch ignore works, but I don't want to use branch ignore, so I'll just comment this out. So let me use control space. So you have this many types of filters available for the push event, right? So currently I only want to use the branches, but you can also use something called as path ignores, tag, or tag ignore as well. Okay, so let me paste the branches. So instead of branches ignore, I can use branches. So when I say branches, so it is going to trigger the workflow if there is a push to the main branch. And we can also ignore certain branches by using the exclamation mark. So here, if you see, I'm using exclamation mark before features /#. So this is going to ignore any pushes to the branches which are starting with feature /#. Okay, so this is how the filtering works for push events using branches. Similarly, I have another event which is the pull request, and for the pull request, we can have multiple activities. So you can use types and you can define all these activity types. Okay, so for this example, I'm only using 2 activities, which is opened and closed. So whenever there is a pull request which is opened and closed, this is going to trigger a workflow. Okay, and I'm also using something called as path ignores filter. So this workflow will only run when a pull request which includes a change to any file other than the README file. Since this is path ignores, so any changes which I make to this README file and raise a pull request, it will not trigger the workflow. It's going to ignore it. Okay, so that is the use of path ignores. Okay, you can also use path as well. And finally, you can also use branches option in the pull request as well. So this is going to configure your workflow to only run on pull request that target this specific branch. So in our case, the main branch. Okay, so this is how you can mention different filters and activities for your triggers. So let us quickly push this to the main branch. So I'm currently on the main branch. Okay, so in the main branch, let me commit and push this. Okay, so if I go to the workflows, I see I have a new workflow filters and activities with a new workflow in execution state. So it's currently queued, and this is going to execute because we made a push to the main branch. Okay, so if I go and check the job, it's going to say that this workflow is executed for event type push. So since we made a push call, right? So push to the main branch is accepted, and hence, it has executed the workflow. Okay, so that is the first example. So in the second example, so what I want to do here is I want to edit a README file, create a new branch, and commit the changes and see how the workflow works. So for that, so let me create a new branch. Okay, so let me go to main. So let me create a new branch called as feature/event testing. So I'm just using a new branch name called as feature/event testing. And I want to create this from the main branch, basically. Okay. So I want to switch to that branch. So in this new branch, I want to edit some, files. So just to understand our example, I will be editing our README file. So currently, I am in the feature/event testing branch. Okay. So if I click on readme.md, I'll just add some random text, okay, and I want to commit this. So once I commit it to the feature branch, edited readme file, okay, so let's see what happens. So ideally speaking, this should not trigger any workflow. The reason here is, so if I go to the workflow filter, YAML file, so if you see here, whenever I'm making any push to the feature branches, it will ignore them because I'm using exclamation here. So since I made a change to the README file and this was part of the feature branch, so it is going to ignore it. It will not trigger any workflow. So if I go to the workflows and if you see here, it won't trigger any workflow. If you see, we don't have any new workflow in progress. Okay, so this is the first example. So we understood, the main push branch and ignoring the feature branches. So now let's understand the pull request. Okay, so now let's first open a pull request and see how it works. Okay, so for that, I would like to use the different UI. So we made a change in the README file in the feature event testing branch. So let's compare it and pull it. So I want to pull, do a pull request to the main branch. I don't want to have any comment over here. So let me just create it. Okay, so it's going to check if it can automatically merge. And as you can see here, it is not triggering any workflow, right? So if I go to workflows, if I refresh the workflow, you see there is no workflow triggered. And the reason here is, again, okay, so the workflow will be triggered if it is of type opened. We have opened it, but we also have a filter saying that it should ignore any changes which are made in the README file. Since we made a change in the README file, it won't, trigger the workflow, right? So out of these three conditions, two conditions were, successful, right? So we have opened a pull request and it was, targeted to the main branch, but, we made a change in the README file. So it is going to ignore it, right? So all the three filters and activities should match in order to trigger the workflow. Okay, so even if I close this, it won't trigger it. Okay, so let me quickly close the pull request. Right, the pull request is closed, so the README file was changed. Okay, so even when I close the pull request, it should not trigger any workflow, right? So again, it is matching the closed activity type and for the main branch, but since we made a change in the README file, it won't trigger anything. Okay, so finally, let's make one last change. Okay, so here we are going to make a change in the ASCII script. Okay, so I'm just going to add a comment. Okay, just for demo purpose, adding a comment. Okay, so let me add or commit this. So I'm committing this in the feature branch, mind you. Okay, I'll just say, modified ASCII script. Okay, and push this. So I'm pushing this in the feature branch. Okay, so let's give it a second. So after you push this, again, you won't see any workflow trigger because any changes to the feature branch will not trigger a workflow. So let's go back and let's go to the event testing thing, right? So we have modified the ASCII script. Okay, so let's go ahead and raise a pull request. So I want to go here. So I want to create a pull request from the from the feature event testing branch to the main branch. So let me create it. Okay, so this time, we made two changes. One is the modified ASCII script and the README file. Okay, but now the latest commit is for the ASCII script. So the workflow should be triggered. Okay, so now if I refresh this page, you can see that a new workflow was triggered, and this is over here. So this is for the pull request. If you see the context or the log message here, so this workflow was executed when I raised the pull request or when I opened a pull request. Okay, so here if I see here, so you can also see that the checks have been done here. So these checks are nothing but the workflow check. Okay, so when I open this, you should see that the hello job is successfully completed, and you can see that this job is executed for event type of pull request. So if I go back once again, so this is for pull request opened, right? So let us close the pull request and see how it works. So let me also close the pull request. So whenever you close the pull request, again, it should trigger a workflow, ideally speaking, right? So if you see a new workflow is triggered, and if you see here, it is for a pull request, which is closed. Okay. So this is how you can make use of, different filters and activities for, different triggers on workflows. In this session, let us quickly understand how to skip workflows. So we can skip workflows which are triggered by either the push or the pull request events by including a command in your commit messages. So the commands could be, skip CI, CI skip, no CI, skip actions, and action skips. Alternatively, we can also end any commit message with 2 empty lines followed by either skip checks true as a value, right? So there might be some scenarios where, you don't want to, trigger a workflow when you make a change, to your Git repositories. So one of the example could be, let's say, or let's assume, we made some changes in a README file, and any changes to a README file won't affect your application code, and you don't want to, test it, or you don't want to run any, workflow for that. So in this scenario, while committing the message, you can add skip CI. So you can use any of the, messages. So I'm just using the first one, which is skip CI. So when you use the skip CI, it won't trigger the workflow. It's going to skip the workflow execution, right? So if you go to workflows, you should not see that any workflows getting triggered. And that is one option of skipping it. And the other option, of course, as we all know it, so if any workflow is in execution or in progress state, you can always cancel it using the UI option. Well, so that's it. I just wanted to talk about how you can skip the workflow runs. So that's all for now. Thank you.